Today we will discuss the third part and the last part of our lecture, which is types of support given in the tunneling construction. Starting with the types of support, number one type, which is steel arches. In tunneling, supports are used to maintain the stability of the tunnel and prevent collapse. Steel arches are a type of support used in tunneling to maintain the stability of the tunnel and prevent collapse. Steel ribs are used for reinforcement of weaker tunnel sections and give rigid to semi-rigid support. The ribs are made from I-beam or H-beam structural steel bent to conform to the requirements of particular tunnel cross section. Timber may be used for packing between the beams and the rock. However, providing continuous bedding against the rock may considerably increase the load bearing capacity of the arches. This shows how the steel arches, or we can say steel ribs, are inserted in the tunnel for the construction and to maintain the stability. Moving further, we have rock bolts. Rock bolts generally refer to as the maintaining the stability by drilling the rocks into the mountain or unstable material, or we can say unstable soil or strata. Steel bolts are frequently set in holes drilled into the rock to assist in supporting the entire roof or individual rock slabs that tend to fall into a tunnel. Rock bolts maintain the stability of an opening by suspending the dead weight of the slab from the rock above. These are the structures. We have introduced the rock bolts suspended in roof, pin strata to form a rock beam. We have given here the rock bolts to pin the strata with each other, which is also a condition of bracing. Here we have give the rock bolt to stabilize the rock that tend to spale. Now coming towards the third type of maintaining stability is the shotcrete. Shotcrete generally refer to the uh, maintaining or expanding the concrete in a very greater speed towards the tunnel or in the wire mesh. Uh, the shotcrete applied mortar and concrete are increasingly being used for the support of underground excavations. A combination of rock bolts and shotcrete has proved an excellent temporary support for all qualities of rock. Shotcrete is best known in tunneling as an integral component of NATM, which is also known as New Austrian Tunneling Method. Quick setting concrete is sprayed into the bare rock surface immediately after excavation and rapidly hardens to form a preliminary support until the final lining of the conventional poured concrete can be installed. Moving further, we have the wire mesh. Wire mesh is used to support small pieces of loose rock or as reinforcement for concrete. Two types of wire mesh are there. Chain link mesh, commonly used for fencing, and it consists of a woven fabric of wire, tends to be flexible and strong. The second type of wire mesh is the weld mesh, which is commonly used for reinforcing shotcrete, and it consists of square grill of steel wires welding at their intersection points. Wire mesh is a type of support used in tunneling to prevent the rockfall and stabilize the tunnel. It consists of a grid of wires woven together. This figure shows how hazardous construction can be there if we don't provide the safety measures during the construction. Now coming towards the ventilation. Ventilation during construction is very important. for the workers, and after the construction is completed, it is very important for the traffic and for the people who are using the tunnel for the passageways or their roadways, etc. Why we require the ventilation? To furnish fresh air for the workers, to remove the dust caused by drilling, blasting, mucking. Mucking is an operation, or mucking is also known as the debris, removing of debris which is fallen under the tunnel during the construction. Uh, Diesel engines and other operations, to remove obnoxious gases and fumes of explosives. How can we done ventilation? Mechanical ventilation is usually supplied by electric fans, as for example axial flow pressure fans. If air is blown into a tunnel, it may be forced through a lightweight pipe or fabric duct. If air is exhausted, it is necessary to use a rigid duct that will not collapse. The exhaust method has the advantage of more quickly removing objectionable air from spaces occupied by the workers. Ventilation during construction is crucial to remove dust, fumes, and other airborne contaminants, ensuring a safe working environment for workers. In tunnel construction, ventilation systems are designed to remove the dust and debris, to control air quality, regulate temperature and humidity, and to provide fresh air. Ventilation of tunnels. Mechanical ventilation systems provide the temperature, humidity, and air velocity conditions necessary to give tunnel users a reasonable degree of comfort during normal operation. When a fire occurs in tunnel, the tunnel must also provide a safe excavation route for the tunnel users and access for fire services for firefighting services. The choice and design of ventilation system depends on these main factors. Number one is that tunnel length and volume, that how or what is the length of the tunnel or the volume of the tunnel we are constructing, and the ventilation provided there will how much the capacity of the ventilation system providing in that tunnel. Admissible air pollution around tunnel portals. Number 3, we have fire safety considerations. Number 4, key pollutants include carbon dioxide, nitrogen oxides, nitrogen dioxide, hydrocarbons, and lead. Better understanding of ventilation techniques, awareness of new safety and environmental legislation. This figure shows the ventilation, how we how we provide the ventilation in a tunnel. This figure shows the big fans which are providing fresh air into the tunnel after the construction. This figure shows the exit route towards in the this figure shows the exit route from the tunnel in case of emergency or fire. This is a CCTV camera view in a construction where we have provided the tunnel shoulders for the emergency purposes, for what we call if a vehicle would damage, or if a vehicle is under different critical situation, they can possess this land. Now coming towards the most important aspect, the geological survey for tunneling. Geological survey generally refers to as the systematic investigation of the subsurface and the surface of a given piece of ground for the purpose of creating a geological map, model, and feasibility studies. Subsurface means the underground surface, and the surface which is finished floor surface. A geological survey employs techniques from traditional walk over survey. Number one, we can have a traditional walkover survey. Number two, we can study the outcrops and landforms, how the strata is there where we have to construct a tunnel. We have intrusive methods such as hand auguring and machine driven boreholes. We have to collect samples from there. Use of geophysical techniques we will discuss later in this lecture. Remote sensing methods such as aerial photography and satellite imagery. Types of geological survey. We have discussed earlier there are two types: surface geological survey and subsurface geological survey. Surface geological survey includes on land geology and geological structures, landforms, hydrology, outcrop pattern, engineering properties, etc. Whereas the subsurface geological survey includes underground geology and geological structures, geohydrology, subsurface rock or soil pattern, etc. Surface geological survey. Surface geological survey is an investigation of the geological conditions at the surface of the earth, typically conducted before tunnel construction. The survey aims to identify the geological formations, which are the map, the types of rocks, soils, and other geological features. Number two, we have a determination of geological structures, which are identified the fault, fractures, and other structural features. Number three, we have the geological hazards. We have to evaluate the potential risk such as rockfall, landslides, and groundwater table. And number four, we have to gather the data for design, which are to inform tunnel design, alignment, and construction methods. Coming towards the most important part of our lecture, where we will discuss how the influence of rock stratification can affect the tunneling construction. Here we will discuss how influence of rock stratification can affect the tunneling construction. Number one, we have geological structures which are dip and strike. These two quantitative properties of rock determine the attitude of the rocks and hence influence the design of excavation to a great extent. There are three geological general cases which we have to be considered. Number one, we have the horizontal strata, which we can see here. There is the horizontal strata and there is the horizontal strata, which are parallel to the construction of the tunnel. Number two, we have the moderately inclined strata, and number three, we have steeply inclined strata. First, we will discuss the horizontal strata, which is here. When we encounter for small tunnels or for short length of long tunnels, horizontal layered rocks might be considered quite favorable. In massive rocks, that is when individual layers are very thick and the tunnel diameter not very large. The situation is especially favorable because the layers would then overbridge flat excavation by acting as natural beams. We can see there we have the layers which are not have a greater width, but it act as a natural beam for the tunnel construction. But when the layers are very thin or fractured, they cannot be depended upon as beams. In such cases, either the roof has to be modified to an arch type or has to be protected by giving a lining, which we can see here that the rock are fractured and they have very thin layers, and we have to deal with the supportive measures in this type. Number two type is that moderately inclined strata, which we can see here. This is a type of moderately inclined strata. Such layers that are dipping at an angle of 45 degree may be said as moderately inclined. We can say it as moderately inclined strata. The tunnel axis may be running parallel to the dip direction at right angles to the dip direction or inclined to both dip and strike directions. Here we can see the tunnel construction, which such layers that are dipping at 45-degree angle. In this situation, that is when the tunnel axis is parallel to the dip direction, the layer offer a uniformly distributed load on the excavation. The arch action, where the rocks at the roof act as natural arch transferring the load on the sides, uh, comes into maximum play. But when we came across the second position, where the dip is not at the angle of 45-degree, we can have a different scenario, which is uh, when the tunnel is driven parallel to the strike of the bed, which amounts to same thing as at right angles to the dip. The pressure distributed to the exposed layer is unsymmetrical along the periphery of the tunnel opening. One half would have bedding planes opening into the tunnel and hence offer potential planes and conditions for sliding into the opening. Here is the construction is very risky. Moving further, we have the folding and the faults. Here folds signify the bends and the curvatures. Folds signify bends and curvatures and a lot of strain energy stored in the rocks. Their influence on design and construction of tunnel is important from at least three angles. Firstly, folding of rocks introduces considerable variation and uncertainty in a sequence of rocks, so that entirely unexpected rocks might be encountered along any given direction. We can see this figure as anticline, and we will have this figure as syncline. In anticline, we have here high pressure and here low pressure, and here at the edges we have higher pressure. But in syncline we have different situation. We have low pressure on the sides and higher pressure in the middle. This shows the anticline and syncline behavior in a tunnel. We have the most safer construction in the anticline, because if we have syncline, it here is the strata and here is the specification. If it will slide here and it will fall, it will collapse the tunnel into it during the construction. Here this figure shows the tunnels which are close to steep slopes. Here is the horizontal strata. Here we have moderately inclined strata. Here we have squeeze strata, and here we have the vertical strata. Here we have a moderately inclined strata, and here we have the fractured rocks. This is the very critical situation in the tunneling construction. These figures show different position of tunnel with respect to fault. Subsurface geological survey refers to the trial boring and the collection of different soil samples from the area where we have to construct the tunnel. Some samples are sent to laboratory for determination of engineering properties like shearing strength, permeability, porosity, compressive strength, and other tests are performed. Groundwater table is noted and water bearing strata is marked in geological profile. This figure shows that how we bore holes in our strata to find different soil properties, etc. This figure shows the demonstration of boring hole in the strata. This machine bore holes into the strata where we have to collect the samples, and then with the help of the data we acquire from the boring holes, the soil properties, we made a map which is like this, which shows different properties where there is weaker material, where there is groundwater table, and these things. We have different geophysical surveys like refraction, resistivity, GPR, ground penetration radar, and borehole logging, etc. Are also done to find different properties of soil. Here is a electrical resistivity test which is used to find the resistivity of soil, which is preferred or which is classified in subsurface geological survey. Then we have the seismic reflection geometry, where we vibrate the earth's surface, and when the rays reflect through different materials which are water, and we have the other materials under the earth, and when these interact with different materials, it will have a different frequency, and we have geophones on the ground to have a clear demonstration of which materials are present down under the earth. This figure shows the recording channels, the vibrator truck and the recorder truck. This figure shows the results of the resistivity test we have conducted for checking the resistivity of the soil, estimated ohm meter, which is a demonstration of checking where the resistivity is low and where the resistivity is high. These are the subsurface profiling 3D modeling of resistivity